Hello and welcome to our webinar on building a data lake strategy with Starburst Galaxy. I'm here today with Tom Natz, our Customer Solutions Director. That's correct, Tom, these days, right?
Sure, whatever you want to call me, Mike.
And I'm the Product Marketing Manager who is tasked with Starburst Galaxy. And so we wanted to show you a little bit about Starburst Galaxy, which we think is the easiest way for you to get started with Trino. And why do we think that? It's mainly because it's super easy to use. You can get started with, querying your data lake within 5 minutes. It has a very simple UI where you can create clusters very easily. It even has management features like you can auto suspend your clusters when not in use after a certain period of time, which you can set yourself. And you can easily connect to your business intelligence tool of choice, your analytics tool of choice, and query data directly from that using SQL. And if you don't have that, you can use our built-in query editor. And on top of that, it's built on top of Trino. So open source Trino, our best-in-class MPP SQL engine, which is designed for flexibility to handle ad hoc interactive queries or batch queries. And you can also set your preferred cost to performance ratio by changing your cluster size, which you can also scale up and down depending upon what the workload is. So you can get the best performance out of it as well. And in addition to that, you can deploy on all three major clouds, AWS, Azure, Google Cloud. And you can enrich your data with various different data sources that we have within Galaxy today, which include SQL Server, Redshift, coming, and more connectors are coming, Postgres, MySQL. More connectors will be coming in the next few weeks and months. And you can federate your queries across those sources. In addition to that, you also have security features built into the platform, so you can connect securely to your data as well. And we should also mention that you can sign up for Starburst Galaxy for free with up to $500 in usage credits. It's at starburst.io/galaxy. And it's free forever, no charges necessary. You can run a free cluster, which you can use to query and test out on your data anytime you want. It's starburst.io/galaxy. We're here today to kind of talk to you about Starburst Galaxy as the data lake query engine. And what that means is you can combine the inexpensive data lake storage with our best-in-class MPP SQL engine. What it allows you to do is to kind of reduce your infrastructure costs with that inexpensive data lake storage, and then also have the performance that you need from the MPP SQL engine that we provide to you in Starburst Galaxy. It is proven at scale at some of the largest organizations in the world, and it can deliver data warehouse-like functionality on the data lake. And so we want to show you that. So I'm going to hand it off to Tom for the rest of it, and we'll go into this. We'll actually describe some of the history of the data lake as well as building a data lake as we go through this.
All right, thanks, Mike. Can you hear me?
Yep.
Oh, good. All right. So yeah, I want to go over a couple slides here of what I think is the history of the data lake and pretty much the EDW data warehousing in general. This is when I started a long time ago. We tried to have Oracle be a data warehouse, and that was difficult, even though they added some features and stuff to try to get us to be able to handle larger type data. And it was more of like long reports, yearly sales reports, that type of stuff. And it wasn't working out. And then that kind of spawned the need for a different way of analyzing this data. And that's where the appliances came out. So like Netezza, Vertica, Teradata, where they would just send you basically these large racks of servers, and you would just put them in your data center and load all your data into it, and out would come much faster analytics. And so we went down that road for many years. And the main reason was you couldn't run large reports on these source systems, as we all know. And so you needed to get that data out of there. And so the problem is the big data boom came. And so the appliances that we saw out there they could scale, but then the costs were so prohibitive. I worked at a sports retail company, and I was part of a migration from Oracle to Teradata, and we were running stuff in probably 8 seconds. That was taking 45 minutes to 2 hours on Oracle. So everything was really great and handy and great. And a year later, we were out of capacity because we threw more data in it, and there was more reports ran, And so we just had to go buy more nodes. And eventually that just became way too expensive because we were starting to pull in all this data from all these different stores. People were coming into the store, so they had a lot more data being produced as far as like when people come into a store, they can kind of track where they were going. Yeah, kind of scary. And so we just started getting more and more data in there. So, and the other part is being able to get that data in fast. I think that was the biggest thing that we came about is we used to have this tradition where we would do nightly runs of the populate the data warehouse, create some reports, and people didn't want that. People wanted data much quicker, especially for reporting. And then we have the explosion of like different types of data formats as well, JSON, text, Parquet, ORC, different unstructured type data that we had to deal with. So if you want to go to the next slide, that's kind of blew up. This kind of came where Hadoop came in at. So we all know where Hadoop came at this point. And so what I saw out there was companies putting Hadoop first. So they would start to load all the company's data. So instead of loading into the EDW, they would load everything into Hadoop. And then we'll try to do some stuff in Hadoop, some kind of structured reporting that just wasn't working out very well. Hive was introduced, and Hive was like a SQL layer on top of MapReduce. But it wasn't ANSI SQL, and all those tools had to be modified. People just wanted to write SQL against their data. And so that came out where it turned into more of like a data science type environment where you had all the raw data shoved into Hadoop, and then you would still take that data and scoop it out to an EDW. So then you had two structures with a lot of copying of data, so a lot of duplication of data in Hadoop. And in Hadoop, you were keeping 3 copies of your data because for redundancy and for performance. So now you had 4 copies of your data, actually probably 5 because you still had it in the source system. So now you copy data everywhere. You have some people on the EDW, you have some people on the data lake. They want to see data that is like lower level atomic data. So they were trying to write these very, very large queries against Hadoop, and it's just a big mess. It wasn't working out. I mean, companies are still doing this right now, and they're struggling to try to figure out where the data's at. And so this is kind of what we see between Hadoop and the EDW. So the next slide, is a lot of companies migrated, they pretty much lift and shifted up into the cloud. And so object stores like S3 and AWS and GCS kind of took place of Hadoop. So they just basically started copying data directly to these object stores in these different clouds. And then they still were searching for a replacement for the EDW. They still needed an EDW. So then they went to companies like Snowflake and Redshift and Synapse. And so we get into our exact same problem again. We have data that's landing in a data lake up in the cloud, and then we copy that data into some kind of cloud data warehouse. And we haven't really done much except for shift a whole bunch of data, not only data, but money from an on-prem data center into a cloud. And then we basically have the same problems. The only part with the cloud is you can spin stuff up much quicker, which means you can spend money much quicker as well. So there were some great advantages of the cloud, but you can see from this diagram, we had the exact same problem. We actually have a little bit more features out there, especially under the data lake, because there are different processing engines out there. There's EMR on AWS kind of took the lead. They have EMR, which is Elastic MapReduce. The idea of EMR is to bring up a bunch of servers, work on a bunch of data that's in S3, and then power down. And so that was like the elasticity of it. And then Athena was born to be able to just query data right in S3. And then you had Trino and some of the other processing engines out there. And that's kind of where we come in at over the data lake. And that's what we're talking about today. So, but majority of the data is still landing on to object stored. Most of the companies I talk to, the data goes to S3 first, and then it goes to, like a cloud data warehouse from there. And that's where the rollups and aggregations happen. So next slide. So the last thing is the cloud data lake. This is kind of what we're talking about here today. The lake has really kind of changed a lot from 5 years ago, 6 years ago when I was working on it, where it was just kind of this schema list type area where people were just dumping data and hopefully they created a schema on top of it so you know what was out there. We couldn't do updates or deletes or anything like that. You had mostly performance problems as people were expecting data coming back in a couple seconds, if not 10, 20 seconds. That's what they were used to in a data warehouse. We're talking minutes, 2 to 3 minutes. Even just a very small query was taking at least a minute to fire up all the MapReduce. And there were some improvements based around that. But we're seeing now in that cloud data lake what we see is the data that's residing in S3 and AWS and GCS can be just queried directly in place. Structures can be built on top of that to be able to satisfy reporting requirements, ad hoc querying, data scientists, sandboxes. So we've seen a lot of the lack of features that people wanted to go, moved into a cloud data warehouse or an ADW. We're starting to see a lot of those features being brought down into a data lake. And there's just less and less of a need to move that data or copy it, make another copy of it and move it to another proprietary solution that we're seeing out there. When you could just have this data just land in one place and start to build all your data, all your objects and structures on top of your data lake. And then also there's the separation of storage and compute. What the difference is between, like an S3 and an engine on top of that, you can have multiple engines on top of that. So you can have one piece of data that's sitting there and then have multiple engines or technologies or vendors work on that data. And that's what's really powerful about the separation of compute and storage. That allows you to also scale up and down on different compute engines and have multiple engines work on this data at the same time. And that just gives you a lot of optionality that we're seeing as people want to land data in one place and not move in and not make duplicate copies everywhere. And then it becomes, what data do I trust that's out there and where's it at? Then you have to have a whole layer of either cataloging, dictionary, documentation somewhere out there that people may get confused and may be querying the wrong data. And that's what we're seeing. It's just like a data geddon, to quote Silicon Valley. That's what we're seeing out there right now. And so what we're trying to do here at Starburst is make sure that you can take advantage of this really low cost storage that these cloud providers provide us and be able to work on that data, keep that data in one place and be able to have people come in with different engines, different clusters, be able to query that data, work on that data, and then especially like for chargeback is be able to, a certain department has their own cluster or set of clusters. They come in, query the data, they process the data, they're looking at it, and they're responsible for their own costs. And that's like a godsend for companies. I remember years ago, I worked at a cable company and we were running Hadoop, and they had 6 different departments, and they all wanted to, we wanted to build them out separately for their usage, and it was literally impossible to try to figure this out. There were some tools out there that we tried to do, but you couldn't, let's say the cluster costs $1 million a year. There was no way for us to separate that over 6 different departments. And especially since 2 of the departments use like 80% of the resources on the cluster. So it was a nightmare. And what we like about, especially with Starburst Galaxy that I'll show you, is each cluster can have its own department and its own use case and be able to control chargeback a lot more. So, all right, next. So the layers of the data lake, everybody has a different name for it. There's different vendors out there with different names. We've been calling it something data warehousing for 20 something years now. On the left-hand side, you can see the raw. It's also called landing stage bronze. It's basically where all the data is landing from the source systems. And when I say source systems, it could be a tightly controlled source system like a CRM tool or an ERP tool, a database like an Oracle database or something like that. And then also we've seen a lot of event IoT type data that's just being streamed in either through Kafka or directly from those sources right into like an S3 or an Azure AWS. And that is just straight raw data. A lot of times the business, if they were trying to query this data, they wouldn't know what a lot of these values mean. So that's why it's called raw. It's just raw data from these source systems. It hasn't been enriched. It hasn't added business terms or business value or joined to other tables that can make any sense to this data. But for some people, they want access to that data, like data scientists. They want to be able to see this data as it's landing in a raw zone. The next one is the base layer. So this is where you're taking that data and either you might be actually aggregating or bringing it up to a different level. So for example, if you have sensors that are spitting out data every 1 second, 5 seconds, 10 seconds, you usually want to aggregate that up to maybe a minute or an hour level to make any kind of sense of it. And that's just too much data. So sometimes you'll actually aggregate that over to the next layer. It's also called structured, silver, refined. There's a bunch of different names for this base layer. I'm gonna keep calling it base because I'll just pick one. And then from there, you're actually joining it in adding, we used to call a structure called ref or reference. And that's where you get a lot of your business rules or definitions or naming conventions. So if I'm coming in, if I have a device ID of 5, I know that's, let's say, a set-top box for a TV company. If I know it's a certain sensor, it could be a thermostat. And so you're adding that kind of layer. So business users, when they query this data, they know that this is a thermostat or it's a set-top box. And so that's why you're not going to get in the raw layer. You're going to get this in the base layer. And then also you're joining this with other data as well. If you have different source systems that are out there, you're aggregating that, you're joining this data together and laying it down in the base. And the base is really meant for pretty much anybody that comes in. They should be able to look at these tables, or either that through like a data products or a data dictionary, determine how to query this data. And the next layer is the reporting layer. So it's also called gold, consumer, analytics layer, presentation layer. There's like 10 different names for it. And that's more of a structured, and that's kind of what, in my old days, that's kind of what the EDW would do. We would do aggregations and roll-ups over in that quote unquote reporting layer. And that's where you would have BI tools and reporting tools be able to look at those structures that are already pre-aggregated or rolled up already and run a lot of their queries. And so you're still seeing that in Data Lake because you can do all this. And I'll show you some examples here in a second where you're creating these reporting structures that are just directly on S3. So instead of moving that to some other, proprietary cloud data warehouse out there, is just leave it on S3, build those structures, and then you can query it with Starburst Galaxy or any other tool that can query data on S3. And there's numerous of them out there. That's the power of it. You're not stuck into some cloud data warehouse somewhere where every time you look at the data, you're being charged by it. Or if you want to use this cool other maybe data science tool that's out there, you're going to have to go through that CDW, that's cloud data warehouse, just to query that data. So now you're paying the cloud data warehouse and you're paying the data science vendor as well. So next slide. So in my example here, I have on AWS S3, I'm landing data into a raw layer here. And it's the first thing you'll see on this diagram where I have different data sources. And this is what we typically see in companies, is data is being landed on S3, either through like an ETL tool or some kind of ingestion tool or hand coding, but that data is just being raw dumped right into S3 bucket. And then that's usually like a JSON format. It possibly could be CSV, like Avro. It's usually some kind of a raw format like that. Usually we don't see like a Parquet or Orc that's being landed here, because these source systems are out there, and a lot of the times IoT, I talked about that before, and event data, that's all JSON type data, and that's readable by the source system. So we'll have a lot of this data being just put right into a raw zone here, or a landed zone as well. And then from there, we will create our base tables. So the base tables in this example is something very basic, right? I just have customer and sales data, but obviously it could be a lot more different types of data here. But the base table is where I'm going to take that and turn that into more of a columnar type format for performance. So like a Parquet or Orc. And on top of that, I have table formats like Delta Lake or Iceberg that I can add on top of that for enhanced performance as well, and partitioning. And what that's going to do is, yeah, you could say that we're duplicating the data. We are duplicating the data, but the data in the landed and raw zone, that should be archived off. I've been in a lot of companies that just stays there forever. And since you're basically copying this data and creating, migrating it to a columnar-based format, there's no reason to keep that data. So maybe keep it around a week or two, but the landed zone should not have years and years of data. That's what the base layer is for. You're not making a whole bunch of changes to that data. And it depends upon company to company as well. So you can see at the bottom there, I have an icon called AWS Glue. So I'm going to use that as a meta store. So I know I have data that's just being landed right in S3, but I don't know what the structure is. So I use Glue, which is a Hive Metastore compatible storage area, to be able to define what those tables look like. So when I go and I want to query the customer table, then I know that I need to ask Glue, hey, what's this customer table? Where's it at? And then what are my columns and what kind of data format it is? Is it JSON? In this example, it is. And then from there, after the base table, as you can see on the right, I have sales by week, by month, by year. So this is just a typical example that we see is, companies get data that's landed directly on S3, and they just need to do some very basic reporting on it. So they want to do ad hoc, and they also want to just create some basic reports for some executives or some, so department heads that just show, the different sales by month, week, and year. And I'll show you how we do that in an example I have. And then on the right-hand side, especially like through Starburst Galaxy, is we have a query editor. And then we also have just BI tools. So integration with all the BI tools that are out there through JDBC or ODBC, which is a standard way to communicate. So almost every single BI tool out there can connect to Starburst Galaxy and just start running queries. And also running ad hoc queries as well. So there's a bunch of SQL tools out there like dbeaver. Again, you could use the built-in query editor. So there's a bunch, SQL is the pretty much standard business language that's out there. So anything that supports JDBC or ODBC, which is almost every single one of them, should be able to connect to Galaxy and run queries. So next slide. So I'm going to go through a couple steps here, and I'll show you some example SQL, and then we'll I'll do a demo of Galaxy on this exact same kind of SQL here, and then we'll connect to a BI tool and show you how easy that is. So I have 3 different steps. So the step 1 is landing data into a raw layer via ingestion tool, coding, or Starburst Galaxy. When I say Starburst Galaxy, means we have different connectors in Starburst Galaxy to like remote databases, Redshift, even MySQL, Postgres. And so we can connect to those source systems and pull data directly into S3. So it's basically just using SQL. It's an insert into or create table right on S3 and select whatever data I want from those source systems. So that's one way of doing it in Galaxy. There's a whole bunch of ETL and ingestion tools out there that will do this. Plus there's built-in like AWS tools that will pull from a source system like Kinesis and push it right to an S3 bucket. So step 1's mostly taken care of in a lot of companies that we're talking to. They already have the data that's landing there. They already have their ingestion tools or they can use Starburst Galaxy. Step 2 is to cleanse, join, enrich, and sometimes aggregate that data to a higher granularity, especially for IoT and event type data. It's such a low level of granularity. We want to bring that up to a different level. And then step 3 is aggregating and rolling this data up into more tightly controlled reporting structures that are either views of that actual data from the base layer or actual tables that we instantiate or we create in the storage just on S3. And so it's very, very easy to do just with the create table statement, and I'll show you how we do that. And again, this could be on S3, AWS and Azure, or Google Cloud Storage. We support all 3. So here's a good example of a raw landing a bronze zone. I call it a land zone. So here's an example of creating a table. So I have data that's just arriving on S3 and it's in JSON format. So I'm just going to create a table. We call it an external table. You can see at the bottom that I have external location. So we're just pointing to a bucket that's out there called sales land. And we have a process that's just dropping files in there constantly that are from our different point of sale systems. And it's all JSON format. So it's very simple. The column format is just order ID, cust, key, product, quantity, total, and order date. So pretty basic for this example. Obviously, it could be a lot more in-depth or detailed at a lot of the companies, but this is just an example. And so once I create that table, I can just run query right over that JSON data. So very, very easy to do. Now, keep in mind, this isn't going to be the most performant. JSON is not the most performant querying because we can't really do any kind of parallelism. We can parallelly read each of the JSON files, but inside a JSON file, there's no way to read that with multiple readers because you got to start at the top and go all the way to the bottom. And so it's not really preferred for longer term storage. And I'll show you that how we're going to take this and move it to the next layer. So next slide. And so this is, we're going to build out this base layer. And I talked about this before. And on the left-hand side, you could see the create table statement. I'm going to use Delta for this. We could use Iceberg as well. And those are just file formats. So basically it still uses S3 and it'll still use like a Parquet or org, but it's just different ways of, instead of storing everything in a Hive metastore like Glue, and that's usually kind of a bottleneck, it's storing everything at a file level. So if you look in S3, you'll see Iceberg metadata information or Delta metadata information. And what happens is we can read that data in parallel much quicker, figure out the structure and the partitions of this table, and go out and query it. We're not relying upon a Hive metastore, which is usually, like I talked about, is the bottleneck in a lot of these very, very busy customers we have. And in the bottom there, I have a pretty easy insert statement. So all I'm doing is saying, okay, I want to insert into the base table where I don't have my order ID that lives in the landing table. So very, very basic. I'm just going to do by day. That way I get some partition pruning. So I'm not going over all my JSON data in my landing table. And so I'm just inserting, I'm running this saying what's every 10 minutes, every 5 minutes, every minute, whatever. It's just inserting new data that's into the base layer that I don't have yet. And it's pretty basic SQL, but you could call this ETL, ELT, whatever you want to call it, but that's how easy it is just to move from one layer to another. It's just SQL. And then on the right-hand side, I kind of talk a little bit about from there, you can provide direct access to the base layer. We've seen that a lot. It depends upon the use case. You might have, things have changed a lot. Before it was, 20 years ago, you didn't have a lot of people that knew Excel. You didn't have a lot of people that knew SQL very well. Now SQL is pretty much the common theme out there. And a lot of times the end users, they understand the data. They're industry experts in what they're doing. They just want access to the data in like a base layer. They can aggregate their own data. They're not really looking to do BI tools. They just want to start querying data and do analysis on the data. So this kind of base layer is usually exposed to end users to be able to query. And then we have role-based access control that we can apply on this as well. So certain groups may be able to see certain tables and certain groups can't. And so in Galaxy, you can actually enable that. So you can have, a cluster for marketing that the finance folks can't use, and then you can have the other way around, and then you can go all the way to a database and schema level and table level as well. Next slide. Then we have the aggregated roll-up gold, whatever you want to call this layer. I call it a reporting layer. I actually didn't call it reporting there, but I should have. That's what I call it. It's just a reporting layer. And this is where you're going to aggregate data. And there's a couple different ways of doing this. Is you can actually instantiate that table. And so the first example I have there, I'm actually creating a table that lives on S3. And so it's going to, by the default in Starburst Galaxy's org, I could have put Parquet there if I wanted to. I could have put JSON, I could put CSV, I could put whatever I want. But for a highly performant type structure that I'm going to be querying with a reporting tool, I want that to be an org or Parquet, one of the two. I just realized that. I want to make sure that my cluster is still running here. Okay, good. That's the worst thing in the world is if hold on, let me run something real quick. That would be awkward if I had to not have my cluster up. Okay, good. I was gonna have that in a different window, but anyway. All right, and the next thing is I could create a view. So let's say I want to query the data that's in that base layer, but I don't want to, when the first example, I'm actually creating the table, and I have to do that. Let's say I have to drop the table every hour. And it's not that big of a deal, but let's say I just wanted to create a view that actually had data already prepared as far as like business rules and stuff like that. So I can create a view on top of this, and it's going to go query that underlying data in real time. So that might be a little bit slower. The first one I have is actually pre-aggregating that data in a table. So for BI reporting tools, it's going to be much quicker than running that view every single time. So I talk about the optionally create views to lower latency needs. And then also publish the structure to be consumed by end users and reporting tools. And then that's the main point of a reporting layer, is to be able to have BI tools come in here, run these reports, and have lightning quick responses, just like they would in a traditional EDW or a cloud data warehouse. All right, so the next thing I want to do is just show a quick little demo. So now I have to get control of my screen.
Yep, hold on one second.
All right.
You are now the presenter.
All right, let me know when you see my screen.
Yep.
Okay, I don't know why that screen's still up, but here we go. Can you see Galaxy?
Yeah, you might want to expand your screen up though.
Okay, these are pretty small. Move that over here. Okay, can you see it okay?
Yep.
Okay, good. All right, so this is Starburst Galaxy. I'm already logged in. This is what the login screen looks like, just so you know. So I'm going to sign in, and I'll be able to deploy clusters in any of the 3 clouds. So the navigation is very simple. On the upper left-hand side, I have a query editor. I have my query history, any kind of queries that I've written. I can get more detail about those queries. I have catalogs and clusters. Catalogs are going to be my gateway to these different data sources. And then I'm going to apply catalogs into clusters. And clusters are going to be able to query this data. So in catalogs here, I have a number of different catalogs set up. I have AWS on Azure. I have Postgres and Redshift and S3. SQL Server on AWS. And then I also have, oh, I guess I don't have it. Not yet, I haven't set it up, but I have Google Cloud Storage as well. And then I have like MySQL and Postgres on Google. So I can connect to all 3 different clouds using Starburst Galaxy. So if I were to connect to S3, I'm going to come in here and I can call it whatever I want. It can be called Data Lake. It could be called whatever I want. Basically, the buckets that I'm going to query, I can name it whatever I want. I'm going to call it S3, just in this example. Kind of description. And then the way I'm going to authenticate into S3 is a cross-account role or AWS key. If I choose cross-account role, I'm going to set up a role on my AWS account. That's going to allow Galaxy to come query the data in there. And it's only going to allow Starburst Galaxy to query the data that I want to. I can basically restrict that all the way to a bucket and all the way down to a folder level if I want to for enhanced security. And again, I talked about the different metastore types. We have our own metastore that we can spin up for you if you don't want to use something like Glue if you're on AWS. And then if you have your own Hive metastore. So I click on test connection and I'm basically ready to go. So it's a couple clicks to really get connected to your data. As you can see, here's the different connectors, and like Mike had talked about earlier, we're continuing to build on to these connectors, and it's mostly driven by our customers. What do our customers want to connect to? And that's how we're driving the product, is really it's a customer-driven product. Next, I'm going to go to clusters. If I want to spin up a new cluster, I can call it whatever I want, call it reporting. I'm going to go over the different cluster size. So I could do a free. Mike, I talked about the free. So this is just for like development purposes and just kind of trying out Starburst Galaxy. And then I have different t-shirt sizes that I can enable based upon the types of queries I'm going to run. I have extra small all the way up to large, and we have some larger ones that we can enable for those larger use cases. And then we have an idle, something called an idle shutdown time. So if the cluster is not running queries, then you shouldn't be paying for it. And that is a cloud pattern. A cloud pattern is bringing up a resource, using it, and bringing it back down and not paying for it. And I think we've lost all that in this cloud industry. In the last couple of years, I've seen companies just go on, just basically just move right on to cloud and just leave resources up running 24 hours, even if they're not even using it. And all that makes the cloud people very, very happy because you're paying them a lot of money, and that's not really the purpose of the cloud. So really, Starburst Galaxy is a cloud pattern. We wanted to make sure that you're not paying for resources when you're not using them. So after 5 minutes, let's say, the cluster is going to go into suspend mode, and then you won't be paying any money for that. And then what happens is when you run a query against that cluster, it'll wake up, power on, run those queries, it'll go back to sleep again. So I'm going to go ahead and run this. I'm going to keep that at 5 minutes. And then what catalogs do I want to connect? It's going to be per a cloud. So I'm going to connect to Postgres, let's say, and then S3 on AWS. And then what region? Notice that I can only choose US East because we're going to deploy in the same region as your data. And then what kind of role-based access control do I want here? Do I want just to be a marketing cluster only, or do I want everybody that's logged in to be able to use it as a public? So anything I want to do, I can go all the way down to the table level like I talked about. So I'm going to go ahead and create that in the background. I already have an AWS cluster running here. And so if I come up to my query editor, I have a couple different clusters to choose here. That's a new one that that was just spinning up now. You could tell that you can see it's starting, but I also have an AWS cluster. So under this cluster, I have multiple catalogs. Remember I had created those catalogs and multiple catalogs into here. So I have S3 as a catalog. So here's all my different structures that I have on S3. This is my demo environment. So I have lots of different structures that are right here that I can query. Again, think of this as these are just a bunch of files that are in S3, and Glue is helping me define and keep track of those different files that are out there so I can use SQL directly against them. So my example I had here is I had that landing table. Remember I had the format equals JSON. So if I select, I had already built this table, but this is basically all you're going to do is create a table that points to that location in S3. And I'm just telling Starburst Galaxy that this is a format of JSON, and it is partitioned by order date. So there's another process that's dropping JSON files into this bucket, but it's created a new directory for every day. And that way you could just tell exactly what day you're on, and it's just easier for the source system to do that. And so I'm going to just run a select statement against that landing data. And this is just going to give me a limited to 1,000 rows. So this is my data that's in JSON. So it's just going out there, reading those JSON files, going to the first 1,000 rows I have and stopping for me. So I can easily see what's going on out there. Next is that base table that I talked about earlier. So very similar columns, but I'm adding some metadata columns in here for the last update date, so I know when those rows were actually created in my base layer. And then I'm doing a little bit something different here. I'm choosing Delta. And Delta is going to give me more higher performance, especially when I'm partitioning, because again, I'm not relying upon the Glue metastore, and I can actually read the Delta logs much quicker than I can to go wait for a Hive metastore to give me that information back. So it's just a much quicker way of querying. So I did not add a select statement in here. So actually I did, yeah. I'll go to it down here. So here's my insert statement again. Here's my insert into my base, and I talked about this before, where I'm just going to query that landing table. Here's my landing table, and I'm actually just going to run this thing per day or once an hour, whatever I want to do. But I want to make sure that I'm not querying the entire sales land data, because that could get very large. If nobody's archiving that data, it could have many, many days out there of data. I have to search through all that data and to try to figure out which order ID that I don't have yet. But if I nail this down to a date, then I could just go to that one directory in S3, read that data, and figure out if there's any new orders that I don't have in my base table. So that's all it is. If I were to run this statement, it comes back very, very quickly. I'm going to go ahead and select star from that base table. It's going to look very similar to the landing table. I've got an extra metadata column in here, but keep in mind, this is going to be much more highly performant, especially if I run, if I just want to know how much sales I did for just coats. It's going to be a columnar format in Delta. It's going to come back much quicker than querying that JSON data. And then I'm going to get into roll-ups here. So this is my roll-up area where I'm going to create different tables based upon my weekly, monthly, and yearly. So in this example here, I'm summing the price and the quantity of each of those orders, and I'm going to, I just want to do my date format of V, which is actually a week. And so if I were just to run this query, it takes about 9 seconds to come up. And so I just want the order date of 1 day in here. And then I'm going to look at the different weeks in here. And so I'm sorry, where the order date. So I just want 2021. So I want the order date is greater than 2021. So I want all the different weeks. So I've got week 1. Here's all my totals. Very, very easy. So I could create a table about this. So I can create a table with this different roll-up information. I can also create a view. So let's go ahead and look at, I think I already have this create table statement here. Let's see, yep, destination already exists. So I already have a reporting table that's out there for the year. And this is what it's going to look like. Very, very easy, but a BI tool is going to be able to query that very easy because it's only 3 rows. I could actually have a BI tool run the SQL statement if I wanted to get that data that's in more real time, I guess. But here's the different way. It's very, very easy just creating these different tables that are out there. So let's say I have more information that came up. And so it'd be very, very easy. So I want to do drop table, and I want to drop that table, and I'll show you how easy it is to run this table again. Now I've deleted that data on S3. It doesn't exist. I'm going to create this table again, and it's going to create those, since I'm not putting a format in here, it's going to create ORC files, and it's going to write that data out on S3. So this takes about 10 seconds there, and then select star. And that's it. So I can come in here and run these statements. I can connect to a BI tool as well, which I'll show you next. And so to connect with a BI tool, I'm going to come in here and look at my AWS cluster that I have running. Notice that my reporting cluster went in suspend mode because I started it up and I've been talking for 5 minutes. So it's gone in suspend mode, which means I'm not paying anything right now for this cluster. Now, if I were to go run a query against that, so let's come into reporting. And if I expand this, it's going to want to be able to pull the metadata out of this cluster. The cluster is not running right now. So if I click back and if I hold my mouse over here, it's starting. If I click on clusters, notice it's starting. So what happens if a query comes in, it's going to go into starting mode. It's going to hold that query up. So the end user is just going to wait a little bit longer, and then it's going to execute that query for that end user. And then you can save a lot of money that way. So going back to connecting the BI tool, if I click on the 3 little dots here, and I click on get connection, I have all the different ways to connect to this cluster through a JDBC URL, using the Trino CLI, and then other clients. And this is mostly for BI tools. So we're going to go ahead and use this. I'm going to copy the host information. I'm going to come into Power BI, make this a little bit bigger here so you can see it. I'm going to click on get data, and I'm going to go to more. And most of the large BI tools we have connectors with, so they're built in directly into the product. So Power BI, if you click on other all in Starburst, you'll see Starburst Enterprise. If I click on connect, it's going to ask me for a host name. I'm going to paste in my host name. My port was 443. If I go back here, I know my port is 443. And then I want to do direct query, which means every time I'm running something in Power BI, I'm actually querying that data in real time on Galaxy versus import, which means I'm going to bring all this data in and I have to have a lot of this data come into Power BI desktop. And I don't want that because I have a desktop. I could be bringing in potentially a terabyte of data and I don't want to do that. I want to just run these queries directly on Starburst Galaxy. So if I click OK, it's going to go out to that cluster. It's going to ask for that information. Notice that this matches exactly what I had in Query Editor here. So if I come into here, I have the exact same thing. So if I go into S3 Lakehouse, and I have a little section under here that I've been creating everything under, which is called blog. And right now what it's doing is asking Glue for this information. So if I go into blog, notice here's my yearly reporting. I also have a view. So if I click on yearly reporting, I click on load, it's going to load the DDL, some information. It's going to run like, I think, a little query against this reporting table just to pull a couple rows back of information. Something that Power BI does in order to get some preview information on that. Let's see, this usually takes about 3 or 4 seconds, but it's taking a couple seconds longer. Then what happens is I'll be able to start running reports against this. So if I bring this over, now I have yearly reporting. So if I click on total and year, make this a little bit bigger, and it's actually running the query. Not very exciting there, but I think, there you go, there's a good one. So anyway, so you can see sales are going down, which is pretty sad. But anyway, that's how easy it is to just query against Galaxy, against S3. So any of their tools, Looker, Tableau, Preset, any of those tools out there support Starburst Galaxy, and it's as easy as just clicking on the cluster and getting the connection information and start to run queries. I think that is my demo there, Mike. I'm trying to figure if I need to go anything else.
Nope, I can share my screen again, hopefully.
Okay, yeah, sounds good.
If I can figure this out.
Oh, I have to stop. I think I have to stop first. There you go.
There we go.
That was the key.
Actually, and now I can't figure out how to share my screen again. Do you mind sharing your screen again? Oh wait, never mind, I got it.
You should be good. I just made you the presenter, Mike.
Okay. Perfect. Can you see my screen now? Yep. Okay. So last thing is that you can sign up for Galaxy again at starburst.io/Galaxy. You can get up to $500 in free credits. Again, it's free forever if you want to try it out. We have free cluster sizes for you to test your workloads on. So that being said, if you have any questions, please put them into the question window. But I see one thing I did want to talk about is just some of the upcoming features and announcements that we're going to have for Starburst Galaxy at Cinco de Trino, which is our upcoming Trino Summit event. We're going to make some announcements on some upcoming functionality, and just to preview that, we're going to be announcing connectivity with Delta Lake and Iceberg coming to Galaxy on May 5th. So look out for that. Tom, one question we did have come in: if you were to start a data lake today, what ecosystem would you go in? What cloud would you go with?
I think it really depends. I mean, we have companies that, most of the younger companies, or digital native we call it, they kind of got their feet wet on Amazon. But we're starting to see not only just one cloud, we're starting to see people that either through M&A or through like different tools within those clouds, like Google Analytics. We've seen a lot of people that are generating data over there, but they're on AWS or they're on Azure. So it really depends. I think the main reason why the success of Galaxy right now is because the clouds are so mature, and I don't want to use the word commoditize because those cloud people will hate me when I say that, but it's really, for us, it's a commodity for us. We have Kubernetes, that's how we deploy. Each of the clouds is a very mature Kubernetes environments now. And so that allows us to have a product that deploys on all three. And we see them as almost basically the same, performance is caught up on all 3 clouds. So that's a tough one. I think it all depends upon the company as well.
Perfect. And I think that is that's all I have in here so far. So
Perfect.
again, we do want to thank you so much for attending the webinar, and yeah, we'll be back in touch with you guys on May 5th at Cinco de Trino.
Good. Thanks, Mike.
Thanks, Tom.